Hi, my name's Haley Perkins. I'm a second year bio major, and today we're going to be helping you guys solve number 4 from chapter 3.1 in the general chemistry workbook. So the problem asks, how many moles are there in 10 grams of each of the following compounds? And before we start solving this problem with you, I encourage you to pause it now and try to solve it yourself if you haven't already done so. The first step in solving this problem is going to be figuring out the chemical formulas for each of the compounds that they have listed. Because if we don't know the chemical formula, then we can't ascertain the molar mass of each one, which we need to convert from grams to moles. So we're going to start with the first one, nickel 2 acetate. When you have a transition metal in a compound, in order to figure out the charge, you have to look at the number that they have listed right next to it. So for nickel 2 acetate, they're telling us that it has a +2 charge, which we get from that number right there. So we're going to have nickel, like this, +2, and then acetate is a polyatomic ion, and it always has a charge of -1, and that is C2H3O2, and it has a -1 charge. So in order to get these charges to balance when they bond together, we're going to need 2 acetates, because they each have a -1 charge, for every 1 nickel, because that has a +2 charge. So our final chemical formula is going to look like this. So we need 2 acetates, we put the 2 outside, like that. So now we need to figure out how much this compound as a whole weighs. So we're going to look at the periodic table to get the masses of each one, and then we're going to add them all up. So we have 1 nickel, and that weighs 58.69 grams per mole. We have 4 carbons, right, because there's 2 in each acetate, and we have 2 acetates. So carbon we have times 4, and each carbon weighs 12, so total is 48. Hydrogen, right, we have 6, 3 times 2, so H times 6. Each hydrogen weighs 1 gram, so total of 6. And then we have 4 oxygens, and each oxygen is 16, so 16 times 4 is 64. And then we're going to add up all of those numbers to get our total mass. So our total mass is 176.69 grams per mole. Now that we have the molar mass, which is the weight of 1 mole, we can go from grams and then figure out how many moles there are in 10 grams. So we'll start by writing out 10 grams, and then we know that there's 176.69 grams in 1 mole. And our units here are going to cancel, and that's all we have to do. So we'll just divide 10 by 176.69. And that's going to give us 0.056 moles. So there's 0.056 moles of nickel 2 acetate in 10 grams. So the next one asks about calcium hydroxide. So we're going to follow a similar process as we did in part 1, but calcium hydroxide is a little different as far as naming because calcium isn't a transition metal. So calcium always has a charge of +2, and you can figure that out by looking at your periodic table. Calcium is in the second row, which means it has 2 valence electrons, so it'll always tend to lose those 2, and it'll form a +2 ion like this. And then our second one here is hydroxide, which is OH. And OH, like acetate, always has a charge of -1. So when we put these together, we're going to get Ca and then OH2, because we need 2 -1 charges for every +2 charge that we have. So we're going to do the same thing as we did before. We're going to find the total weight. Here we have 2 oxygens and 2 hydrogens. So it's 2 grams. That one is 32 grams. And calcium is 40.07. So when we add all these up, we get a total of 74.07 grams. And we're going to do the same thing we did before. So we start with 10 grams, and we're going to multiply that by 1 mole over 74.07 grams to get how many moles we have in 10 grams. Because again, our units here cancel. And we get 0.135 moles.
So the third compound we have is chromium 2 carbonate. Following the same rules as we did in part 1, we can see the chromium ion has a +2 charge, and the carbonate has a -2 charge. Therefore, the total formula will be CrCO3. So now we will follow the same steps as before and divide by the molar mass. So the last compound we have is sulfur dioxide. This is a covalent compound. So to obtain the chemical formula, you must look at the prefixes in front of the elements in the molecule. Sulfur has no prefix, so we can assume that it is 1. Dioxide indicates that there are 2 oxygens, giving us the formula SO2. So again, we will follow the steps from before and divide 10 grams by the molar mass to yield 0.16 moles of sulfur dioxide. So now we've found how many moles are in each of them. If you wanted to reason through this a bit, just to double check your answer, you could see that the heaviest substance, nickel acetate, also has the fewest amount of moles. Using a feathers to bricks analogy, if you had 10 kilograms of feathers and 10 kilograms of bricks, you would have a lot more feathers than actual bricks, even though they have the same mass. Hope you enjoyed the video. I hope this helped you understand the concept of finding the amount of moles of a substance for a given mass. Thank you, and take care.